So today I'm going to create a car controller with a camera that's going to look like this. It's basically a pretty simple car controller. So that's when you press start, it goes forward, it brakes, it goes backwards, and so if you want to steer, it also helps you counter steer. So when you're drifting, it goes and actually drift and does not do a 360. And it's a pretty simple and fun car controller to play with. So first thing we need to do before getting started is to actually set up our car prefab. So this is basically a simple model with 4 wheels and a plane, a cube, that's the spoiler, and that's basically that. So to get started, we need to actually set it so that it uses the Unity physics. So we need to add rigid body on it. So we add the component of the rigid body to the car. And next thing we need to do is add a collider. So a box collider will be pretty good. So we set up the box collider so that it matches the car, kind of. We do need to make sure though that the collider does not interfere with the wheel, so we will move it a little bit upwards and a little bit down, I guess, so that we can match the car. And next thing we need to do to set up the physics is get our wheels here, duplicate them with Control D, and add a wheel collider to them. So we will have a wheel collider for each wheel, as you can see. And we can also remove the mesh renderer, since we will not use it on the duplicated wheels. So now we have the the rear right wheel collider, rear left, etc. But as you can see, the radius of the sphere of the circle is huge, so we can actually make it a bit smaller to match our needs. So we select all the wheels and make the wheel collider around 0.5, I think. But now we cannot see the wheel collider. As you can see, it's below the ground. So to fix this, we need to make the suspension distance 0.01, for example. And then we need to still make the radius a little bit smaller to around 0.02. Yep, this works. So now, as you can see, we have the wheel colliders that are set up that match the wheels that we have on. We can also rename them so that we know what we're looking at. To basically, what's this called? It's rear right wheel collider. Yeah, all right. So now to have our wheel colliders, we can check if the physics work. But as you can see, the car is actually flying, which is not what we want. Yep, has been. Yeah, that's probably not a car. So to fix this, what happens is, because we have 4 wheels, these wheels are meant to be used on a 1-ton vehicle. So Unity has actually set it up so that when you use wheel colliders, the force that it puts on the ground when it hits is for a 1-ton vehicle. And right now our car is, as we can see here, it's 1 kilogram. So you put a 1-ton force on a 1 kilogram car and it just starts jumping around, and we do not want that. So to fix it, we just put it as a 1-ton vehicle, and this should work. Yep, as you can see, the car, it's simple, it works. If we put it like, yeah, if we increase the height, it falls, it kind of falls back, leans backwards a bit, and bounces. But for now, nothing really happens. The wheels don't really move. If we look close enough, we can see that the wheel collider is moving, but the wheels are not moving, so we need to fix that. So we need to start the script. So we create a new script, we call it car controller. And now we open it. We wait for the script compilation and we open it. All right. So here's the script now. So to get started, we need to create a data structure so that it holds our wheels. So to do it, it's pretty simple in Unity. It uses classes. So we can use a public class, which is we will call it wheel colliders. And so we put there the wheel colliders. So front right wheel, if I spell it correctly. So front left wheel, and so on, so on. All right. So if we use this data structure right now, it won't show up in Unity. We need to tell Unity to use it as a data structure. So we need to specify it's serializable. And now we can use it on our car controller for as a data structure. So we will use it as a wheel colliders. Yeah. So colliders. Yeah. So now we go back to Unity. We will see that our script actually has this little arrow here and has our 5 wheel colliders. So we go back to our script and copy paste it so that we create our wheel meshes as well. And now just set this as a mesh, 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 and mesh again. So right now we will have, oh wait, yeah, forgot to include the wheel meshes. So right now we include the wheel meshes as well, and we call it wheel meshes or whatever. Yep. And so if we go back to Unity, we will see that we have 8 attributes that we can set. It's the colliders and the wheel meshes. So we will go ahead and do this. So that's the rear right wheel collider, rear left wheel collider, front right and front left. And again, if we go to this is rear right, if I'm not mistaken. Oh, yeah, sorry. So this should not be a mesh, it should be a mesh renderer. All right. I think I saved it. Yep. So we go back, and this is front, rear right, rear left, front right, and front left, if I'm not mistaken. So let's check. Yeah, so that's correct. So right now we have saved our data, and we can go back to the script and actually use it. So we will create a new function that actually updates the meshes to follow the wheel collider. So we will call it update wheels, I guess. And so all we have to do now is update our wheels. So to make the code a little bit cleaner, we will actually create another function that takes as a parameter update wheel, that takes as a parameter our wheel collider, and our mesh renderers, and we will update it. So to do this, it's pretty simple actually. All we have to do is go to the, sorry. So we now have to get our wheel collider and get our position and our quaternion, which is basically the rotation of the scripts. So we will create a new quaternion. We will call it, I guess, quad. It's a pretty simple name. Also a vector3, which will be our position. And now we need to get the rotation of the wheel collider and the rotation, and the position of the wheel collider, so that we can apply it on the mesh. So to do it, Unity provides a function which is get world position. So we just go to the call, our collider, our wheel collider, and the get world pose, and the output will be the position, and the other output will be our quaternion, which is basically the rotation and the positioning. Oh, oops, I wrote that wrong. Perfect. So now that we have the rotation and the position, we actually apply it on our wheel mesh. So we will get that transform and we will apply the position. We will also get its rotation from the transform, and apply the quaternion that we got from the get walls position. So let's check it out. So now that we have all these correctly set up, this should work, theoretically. Okay, so as you can see, when I throw it upwards, the wheels do not move. That's because I forgot to actually use the function. Yep, that's a bad thing to forget. Come on. Alright, you got to be kidding. Alright, so to actually use the function, we go to the update wheels and we will call it for each of our colliders. So we will go to our colliders.front right wheel and wheel mesh is front right wheel, and we will do this for each wheel. What's wrong here? An overload takes what? Oh yeah, sure. That's actually a bad name. I should change it. So apply wheel. That's a better name. So now this works, and we do it for each wheel. So let's copy paste it. Do it 4 times. Front left wheel, rear right wheel, rear right wheel, rear left wheel, and rear left wheel. Okay, so we now call this function from our update, and it should work as intended. Alright, let's check it out. Alright, so now when we move the car, you can see the suspension working, and if we kind of make the car fall a little bit, you can see that the wheels roll back as well, which is what we want from a car. So now what we want to do is actually have the engine move the car forward, so actually rotate the rear wheels of the car and steer the car left and right. So to do this, we need to get the component. So we need to create a function that checks the input. We will also, create a public float point, which will show the gas input, which is basically the forward motion or the backward motion, like pressing the pedal, and the brake input as well. And so we will use the gas input. If it's positive, it will move the car forward, or if it's negative, it will brake the car. So input, and we will also get the steering input. So I have it as a public float so that I can see what's going on. Alright, so now we go to our check input void, and we get the input from the input manager. So we set the gas input to be equal to the input dot get axis. I think it's horizontal. No, it's vertical, if I'm not mistaken. Let me check. So yeah, it's vertical for the gas input, which is basically the up arrows and the W and A, W and S. And the steering input will be equal to the input dot get axis dot horizontal, which is the left right input. Perfect. So let's check that it works first of all. And I have not called the function once again. Alright, so let's check if it works. So here is our gas input and our steering input. Let's check. So when I press the W, as you can see, it goes to 1. If I press S, it goes to -1. If I press left, it goes to -1. The steering input, and the steering input goes to 1 if I press the D. Perfect. So we actually know now when to move. Now we need to apply the logic behind the movement. So to do that, that's actually pretty simple. Let's create a variable that says the motor power, I guess. And yeah, so let's create the motor power first. Let's create a function. We will call it apply motor, which is basically how the engine will work, how it will increase the motor speed of the wheels. And now it's actually pretty simple, because we just multiply our gas input along with the motor power, and we get how much the car should accelerate. So we apply that to the wheel collider, and the car moves. So okay, let's see that. So we go to the colliders, dot rear right wheel and rear left wheel, and we apply motor torque, and we equal that to the power times the gas input, and do that again for the rear left wheel. And let's see what happens if I Alright, let's check it. As you can see, the car is not moving. Oh yeah, so the car is not moving because we have set the motor power to 0, which is logical. With 0 power you cannot move the vehicle. So let's set it to 100 to see how that works. Let's see. Okay, it starts moving. That's good. It's a bit slow right now, but it works kind of. And if we press the back button, it goes backwards slowly. And so we basically have a really basic movement of the car. So let's put the camera a little bit on the side so that we can see what's happening. Alright. Perfect. So let's increase the car power just a tiny bit to 500. Alright. So as you can see, the car is moving right now, and it stops. Although it doesn't stop with brakes, it stops by moving the wheels backwards, which is wrong, which we should fix that after we make our steering system. So to create a steering system, some people just use a normal steering, so when you press left it goes 60 radians on the right and all the time, no matter the speed, but that's actually really wrong, because when you're going 100 miles per hour you don't just go right and expect the car to either steer or not die. So to fix that, we will use a curve, so that we have a function over the speed and the angle of the car. So to do that, we need to have the speed of the car. So to do that, it's pretty simple actually. We go to the update, we go to the speed, and we get it from the rigid body. So before we do that, I have forgotten to add a rigid body component to the script. So layer rigid body. And we need to get that component from the player. So to do that, we do a player rigid body is equal to the game object dot get component, and get the rigid body component from the game object. So the speed will be equal to the player rigid body dot velocity dot magnitude, which is basically the how big the vector is of the velocity, because in 3-dimensional space the speed that the car is going on, I guess, kind of. So now that we have the speed, we can actually create our function. To do that, we will create a new curve, which we will call it steering curve. Keep in mind that Unity uses animation curves to process curves. It's pretty much the same thing as a curve, as a function curve, and so do not worry about the name of it. And so we will create another function, and we will call it apply steering. So to do that, we will create function steering angle. Sorry, a function, not a function. A floating point called steering angle, which will be equal to our steering angle. Do I have it already? No, yeah, steering input. Oh, sorry. Actually, I'm not sure why I put the public floater. That's wrong. Which will be equal to the steering input times the steering curve that we will create. But we can't just take a curve as a parameter. So we will need to evaluate at what point the axis is where. So when we have a curve that's at 60 miles an hour, it's at around 20 degrees. And if you go to 20 miles per hour, it's around 60 degrees steering. So you need to evaluate where you're at. And so we just put the float, the speed in it. So now we have our steering angle. We can actually apply it to the front wheels. So we go to colliders, don't front wheel, and steering angle is equal to our steering angle. All right, so we do that to the front left as well. And let's check if it works. Let's apply it to our update component and let's check if it works. Okay, so as you can see here, we have a steering curve, which is this thing right here. So we will create a curve. I will put it somewhere around here and this here. Oh, it's wrong. Okay, let's create it from the ground up. All right, so we need to go to the 60 degrees angle. So that's around here. 65 is a good degrees. And go to around 50 miles per hour, I guess. All right, so that seems like a logical steering curve. Let's do it 60 miles an hour. Yeah, okay, that looks okay. So now that we have our curve, so let's actually not make it 0, let's make it around 20, 15, yeah, 15 makes sense. Okay, so now that we have our steering curve, this should work and it should actually rotate our car. So as you can see here, the car wheel is moving left and right. So when we move forward, it steers, and when the car is going faster, it steers a bit less, so that it actually works like a car. And where did I go my car? Ah, so it's here. Okay, so it's steering. All right. So now it seems like it kind of is understeering here. So we can actually increase the traction of the wheels by the forward friction. We can increase the stiffness of it to 2, and the sideways friction as well to 2 for the front wheels. Let's see if that makes any difference. It should make it steer a little bit easier. Yep, although now it is actually just tipping over. So to fix the brakes, we need to get the angle of the wheel that's moving. So basically, when a car is moving forward, you need to check that it's actually moving forward, not backwards. And you need to do that by checking its angle against its velocity. So this is the forward angle. So when it goes forward, it goes like that. But the velocity angle can be like either matching or it can be moving. So if it's going sideways, if it's going like this is going to be the difference. And as you can see, there is like a 30 degrees angle, which we call it a drifting angle, if I'm not slip angle, I guess. So we need to check that's actually more than 120. And if it's more, then we will reverse the car. If it's less, then we will apply brake pressure. So, okay, let's do that. So, we will create a new variable, which we will call brake power. And we will also create a private field, which we will call a slip angle. And we will actually monitor that. So to monitor that, the slip angle will be the signed angle. So the signed angle of the player. So our transform dot forward, which basically the forward vector of the car, which does not change no matter how the car is moving. and our velocity vector, which is basically where the car is going. So if the car is going like this and it's looking forward, like so, it's slipping, it's going sideways. Our velocity will show the sideways motion. So we will go to our player rigid body dot velocity. Okay. The calculus sign. Yeah. So we need an axis. So it's basically at what dimension we calculate the vectors from. So because we're basically looking from the top down bottom to see where the car is going, the axis will be the vector theory dot up. Okay. So now if the slip angle is more than 120 degrees, so so if it's less than the 120 degrees, so if it's going forward, and if the gas input is lower than 0, we will actually set the gas input as equal to 0 and our brake input as, oh yeah, we need the brake input as well, forgot that, as the gas input. Sorry. Yeah, so brake input is equal to our gas input, and then we reset the gas input. Okay. So this brake input, we will use it on another function, which we will call it apply brake, which we will apply brake. So we will apply the brake on all the wheels, but a bit less for each wheel. So the front wheels will be around 70% of the braking power and 30% will be the back. Since the car, when it's going forward, it's braking, it's naturally pointing the nose down. So okay, let's do that. So we will go to the colliders, dot front right wheel, dot brake torque, which is different from the motor torque, will be equal to our brake input times our brake power. And we will do that for each wheel. Okay. So front left wheel, rear right wheel, and rear left wheel, if I click it. Okay, but this will be around 0.7 our brake power, 7 again, and yeah, forgot the F for float. And this will be around 0.3 floating points and 0.3 floating points. And let's check it. This should work and it should brake. So let's check. Okay, it's not working. Why is it not working? Oh yeah, so we don't have applied this. If it's yeah, so else the gas input will be sorry, the brake input will be 0. Yeah, it's not working because I did not make the brackets correctly. Okay, so let's check it. So the car controller, we will increase the brake power to something like 50,000, since the brakes produce a lot more power than the motor. So let's check if this works. Okay, so it's moving forward, and if I press the brakes, it does not brake. Does not brake, no. So let's check that's doesn't have something to do with the values that we have added. Yeah, it does not have something to do. Yeah, so the problem here is that we are actually having a negative brake input, and the brake torque does not take negative numbers. So to fix this, we will basically just make this get its absolute value, which is pretty easy. Let's check again if this works. All right, so this works and it still doesn't brake. Okay, so let's check if the gas input is lower. So that, oh yeah, so once again I forgot to apply the brake function. Okay, let's do this now. This should work. So okay, this brakes. As you can see, that's actually the braking motion. So it goes forward and it stops. That's the perfect stopping motion. And now it doesn't go backwards because it does not know that when it's not moving, the vector can be forward, backwards, can be everywhere. The velocity does not change. So we do not have a steering angle. So to fix this, we can actually just make the player velocity to be the vector. So if it's 0, to be negative. So we actually we add the transform forward position, but actually the transform backwards position. So when it's the velocity 0, it can actually detect that the slip angle is negative. So let's actually check if this will work, and it should work. It shouldn't not work. So let's see. Okay, it still doesn't go forward. Yep. Okay. Actually, let's check the slip angle of this function. Okay, so the slip angle is oh yeah, I have actually no idea why I put the signed angle. So we just want the normal angle, so we do not need the vector up. It's basically just an angle. So let's check it once more. Okay, it goes forward, and it still doesn't go backwards for some weird reason. Oh yeah, because we have not reset the brakes, so we need to reset the brakes outside the slip angle. So yeah, let's do this, and let's keep the other one as well. So I think this should work. Okay, so going backwards, perfect. And now it goes forward, it brakes, and it goes backwards, perfect. So let's check, it works, it goes left, right, it brakes, and goes backwards, perfect. So the final thing I want to do to this car controller is to detect when the wheels are slipping and actually create a smoke particle on the wheel. So to do this, we go to our script and we create a new class, which we will call our how will we call it? Smoke wheels particles, I guess. And we will create one for each wheel. So it will be a game object. Or actually, yeah, let's make it a particle system. And let's put it on all the other wheels. Let's make this public wheel particles. And so instead of having to put the particles from the start of the vehicle, we can instantiate them from when we start the game, from the position of the wheels. So to do that, we will create a new void, which we will call instantiate smoke, in which we will create a new array of particles, which I forgot for some reason to have them. So yeah, a new array of particle system. We will call it particles, which will be of size 4. I have no idea why it's throwing me an error. Oh yeah, I forgot to actually make it an array. So the particles, actually I have no idea why I did that. So the particles from the wheel particles will go to the front right wheel. So we will instantiate a new prefab, which will be our smoke prefab, which we need to set it. So public float smoke, not float, sorry, game object smoke prefab. So we will instantiate our smoke prefab, at the position of the wheel collider. So colliders dot front right wheel dot transform dot position and quaternion dot identity, which means it will have no rotation, and get the component of the particle system. All right, so that's pretty big, but I think it works. Let's make it like this. Okay, so let's do this for each wheel. So now we have the wheel colliders. Actually, the wheel particle is actually instantiated, but we do not want them to start when they are instantiated. So you will see what happens here. Let's put our smoke particle on the smoke prefab and let's check out what happens. Yeah, I forgot to make this system serializable so that we can see what's going on. And so, let's see what's going on. As you can see, it has the smoke particle, but it's working right now, even though we do not want them to be smoking, and it doesn't even follow the car. So to do this, we can actually make the wheel collider its parent. So this will be the parent. So it's the fourth variable. This is going front left, rear right wheel, and rear left wheel. And so this should move alongside the wheels. Let's, oh god, yeah, so I think this is a bit too big for some reason. Yeah, maybe that's why the radius was 0.3. Yeah, that makes sense. All right, so let's check it out. And now if it works, it should work. Okay, so now it does have wheel smokes, but it's in the middle of the wheel, and it doesn't look really, it looks pretty meh. So to fix that, we can actually make the smoke be a little bit lower by actually getting the diameter of the wheel. So we got the radius and we just decrease that from the position. So this will lower the smoke particle. So let's check it out. Okay. So this should be around here. Yeah, so as you can see, that looks a little bit more okay. But now we need to enable that to only work when it's sleeping. So instead of making this start when the car is instantiating them, we close the play on awake. And so now we need to check if the car is sleeping. So we will create yet another function, which we will call check particles. On this function, what we want to do is to actually check if the wheels are hitting the ground and if they're sleeping. So to do that, we need to create a new wheel hit array of 4, which we will call wheel hits. And we will make the FR wheels, the FR wheel to get the ground hit to the output of wheel hits 0, and we will do this. So front right will be 0, front left will be 1, rear right will be 3, rear right will be 2, and rear left will be 3. Just so that we do not create 4 different wheel hits. So this will be 1, 2, 3. Okay, so front left, rear right, and rear left wheel. So now we want to get if the wheel is slipping. So to check if the wheel is slipping, we need to create a new if statement. But before we do that, we will create a small float, which we will call the slip allowance, which will be 1.1f, which we can change, which will be basically how much slip is allowed before the particles are started. So now we create a new if statement, which we will get the absolute value of the wheel hits, slippage, dot sideways slip, and we will also get the vertical, the forward slip. So wheel hits dot 0 dot forward slip, and this should be bigger than the slip allowance. So if this is true, then the wheel is slipping, so we will have the front right wheel, front left, so the wheel particle dot front right wheel dot play. Else, if this is not slipping, I forgot the semicolon here. So if it's not slipping, we should stop the particles. Alright, so we do this for each wheel. 1, 2, 3, 4, and 1, 1. Something is wrong here. So yeah, I did not close the parentheses. Okay, so this will be 2, 2, and 3, 3. So front left, if I actually type it correctly, left, front left, rear right, rear right, rear left, and rear left wheel. So let's check out if it works now. So we put this at the end, at the check particles, and please work. All right, let's check it out. Okay, so it doesn't show any particles, which is good. And as you can see, the wheels are slipping on the back, and so it's starting, and when we turn, the wheels are slipping as well. And so now that it's not slipping, it does not show any smoke, so only when it's slipping. So we can actually change how much slippage we allow here. So we can change it from 0.1f to 0.3, so it has less smoke. We can actually also make it a public variable, but this should not really be changed that much. So as you can see, only when it skids, it actually throws smoke, which is exactly how we want it. And finally, we will create a script so that we can, so that our camera will follow the player. So let's create a new script, which we will call camera controller. All right. So we will go to the camera controller. So we will create a new transform. So we get the transform of the player. Transform player, and we will get a rigid body of him as well. So the player rigid body will be equal to the player.getComponent.rigid body. Okay, so what we want to do now is to make the player, the camera to look at the player and to move the camera according to the player. So to do this, we also want to have a public vector3 for our offset, which will be how offset our camera will be, and a speed float for our camera. And yeah, so we go to our transform, which is our camera parent position, to be actually equal to vector3.lerp, and we just make the camera to move. So the transformed position, which is the camera position, to move to the player position, which will be our vector 3, which we will call player forward, which will be the offset based on the velocity of the player, which we will set as player dot velocity dot ARP, sorry, dot velocity, if I tablet correctly, times the player rigid body, the player dot transform dot forward, which will be, for the same reason we had the forward component, so that if the rigid body is 0, it will actually look forward and not in a random place. So now we move the transform position, so the camera, to the player position, plus our player dot transform direction, sorry, transform vector, which will transform our vector offset. And we will also add the player forward and increase it by -5, I think is going to be a good value. And then move this by speed times the time that each frame takes. Okay, and finally we look at the player. And this should work. I really hope it does. Okay, so we look at the player. We offset this so that we increase the height to 2 and make the speed 5. Please work. Okay, it works. Yeah. Okay, it's not as smooth as it should be. And this is because... Okay, and so this is because we updated on the update and not on the late update. So this should fix the problem. We can also decrease the speed of the camera a little bit. And let's check out how this works. All right, so that's a lot more smooth, as you can see. And it works as a car should. So it's increasing, going on the left, right. It's not slipping in any way or form. And if we want, we can actually make it a drift car as well. So we do this, so we just need to make the stiffness, the actual multiplier of the friction of the rear wheels, to be a little bit lower. So that's going to be 0.5 and 0.5. And as you can see, now the wheels are always slipping, and has a little bit of a more fun way to move. Yeah, as you can see, it's throwing its rear on the end. We can actually also make the wheel slip at a bit lower by increasing this to 0.5. And instead of changing the stiffness, we can actually change the extremum value to 0.5, 0.3, 0.4. And let's check now the car. We can also increase the motor power to 1000. And let's check if this works now. Okay, this kind of works, but it's a bit slow. It does throw its rear end a little bit. But that's a basic car control right now. It's kind of drifting, as you can see. The main problem right now is that the wheel is slipping all the time, which we do not want that. So we need to play with the motor power and the slip angles and the slippages to check when the car will slip. But other than that, it works as expected, and works like a pretty okay car controller. So what I ended up changing was basically just make the asymptotes even smaller and make the forward friction to 2. So as you can see now, when you press the forward button, it moves okay, and it actually sleeps, well, like it should. So before finishing, I would actually want to fix the car from when it's drifting and actually help the player by counter steering. So if it's sleeping on the right, it will steer right, so it goes forward. That's actually pretty easy to do. So we basically just want to go to our script, and here that we have our apply steering, we can actually make the steering angle to increase it by finding the angle that's sleeping at. So we can actually do a vector 3 signed angle and find the transformed forward angle compared to the player rigid bolted velocity and the transformed forward as the other time, so it doesn't bug out when it's not moving. And the axis will be the vector 3 dot up. And so that the wheel doesn't go backwards, we will clamp this down to, so mathf dot clamp the steering input, the steering angle, comma, from 0 to 90 degrees, which should be pretty good. No, actually we clamp it, but we did not clamp it to 0, we clamp it to minus 90f, that was my bad. And let's check now. This should work. Alright, so when it starts sleeping, it detects slippage. As you can see, the wheel is moving on its own sideways, which is what we want it to do. So let me decrease this to 1.25, 1.25, and let's check it now. This should be pretty fun. So when it detects slippage, this happens. And so the car is basically drifting on its own without me actually pressing any buttons. So that's pretty fun. So when I press left, it goes left, as you can see. And if I press right, it goes right. Even if it's drifting, it will go right or left, depending on what I press. Yep, so thanks for watching once more, and take care, and I hope the tutorial has helped you.